How hard is the multi-protein folding problem? Is that kind of something you've already mentioned, which is baked into this idea of greater and greater complexity of proteins, like multi-domain proteins? Is that basically become multi-protein like complexes?
It's yes, you got it right. So it's sort of, it has the components of both of protein folding and protein-protein interactions. Because in order for these domains, I mean, many of these proteins actually, they never form a stable structure. One of my favorite proteins, and pretty much everyone who works in the, I know, whom I know who works in the, with proteins, they always have their favorite proteins, right? So one of my favorite proteins, probably my favorite protein, the one that I worked when I was a postdoc, is so-called postsynaptic density 95, PSD 95 protein. So it's one of the key actors in the majority of neurological processes at the molecular level. So it's a key player in the postsynaptic density. So this is the crucial part of the synapse where a lot of these key molecular processes are happening. So it has 5 domains, right? So 5 protein domains. It's a pretty large proteins. I think 600 something amino acids. But the way it's organized itself, it's flexible. Right? So it acts as a scaffold. So it is used to bring in other proteins. So they start acting in the orchestrated manner. Right? So, and the type of the shape of this protein, it's in a way, there are some stable parts of this protein, but there are some flexible. And this flexibility is built into the protein in order to become sort of this multifunctional machine.
So do you think that kind of thing is also learnable through the AlphaFold 2 kind of approach?
I mean, the time will tell.
Is it another level of complexity? Like, is it like how big of a jump in complexity is that whole thing?
To me, it's yet another level of complexity, because when we talk about protein-protein interactions, and there is actually a different challenge for this called Capri, and so that is focused specifically on macromolecular interactions, protein-protein, protein DNA, etc. So, but it's there are different mechanisms that govern molecular interactions and that need to be picked up, say, by a machine learning algorithm. Interestingly enough, we participated for a few years in this competition. We typically don't participate in competitions. I don't know, don't have enough time, because it's very intensive. It's it's a very intensive process. But we participated back in about 10 years ago or so. And the way we entered this competition, so we designed a scoring function, right? So the function that evaluates whether or not your protein-protein interaction is supposed to look like experimentally solved, right? So the scoring function is very critical part of the model prediction. So we designed it to be a machine learning one. And so it was one of the first machine learning based scoring function used in Capri. And we essentially learned what should contribute, what are the critical components contributing into the protein-protein interactions.
So this could be converted into a learning problem, and thereby it could be learned.
I believe so, yes.